What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today our lesson is going to cover 5.2 congruent polygons. What we're going to be able to do is to identify and use corresponding parts, and then also use something called the third angles theorem, which we'll get more to at the end of this video. So if you need just that theorem, go ahead and scroll about halfway through. That's when we should be getting to it. Otherwise, let's go ahead and jump into corresponding parts. Corresponding parts are always going to be congruent. So when we look at these two shapes here, it says write a congruent statement for the triangles and identify all parts of the congruent corresponding parts. We just want to make sure we pay attention to the tick marks and the arcs that are inside the angles and identifying the sides. So looking at this, we know that we can probably state that triangle JKL, so notice I'm starting here, then here, then here. JKL is congruent to, if I started with J, I also need to start with something that corresponds with J, and that's going to be letter T. So triangle, T, then S, then R. Okay? It's very important that you line up the corresponding angles when you start to name your shapes. Because I know this, now I can start to name all the corresponding angles and sides. Let's start with angles. Angle J is corresponding to or congruent to angle T because they both have that 2 tick marks within them. Angle K is congruent to or corresponding to angle S because they both have 3 arcs in there. And then angle L is congruent to or corresponds to angle R. Now let's talk about our sides. The sides that are congruent are going to have those same tick marks. So side JL is congruent to side TR. Okay. Side JK is going to be congruent to side TS. And then side KL is going to be congruent to side SR. Okay. One way you could also do this, once you're done naming your shape, JKL, you just stack it on top of the other shape, TSR. And notice J is matching with T, K is matching with S, and L is matching with R. And that just creates a little bit of an easier way to name it because you can see that if I wanted to say, what is KL congruent to, I would say SR because SR is right underneath KL. Okay. This next one states that DEFG is congruent to SPQR. So what we're going to do is try to find the value of X and find the value of Y. One thing I already know is I know that here's my X and it says that QR is 2X minus 4. Well, QR is matching up with FG. So that means QR, the 2X minus 4, is equal to FG, which states it is 12. So I would add 4 to both sides. 2x is equal to 16, so x must be equal to 8. Okay, so it's just very important that you pay attention to what and where goes what and where. Okay, this little guy over here, this 6y plus x, is going to match with something. It looks like it's in the corner for Q, which means it's going to match up with the corner for F. So Q and F are equal, so we're going to say that 6y plus x, which is now plus 8, is equal to 68. Next, I'm just going to subtract 8 from both sides. I'll get 60. So 6y is equal to 60, which just means y is equal to 10. Okay? Next up, you divide the wall into orange and blue sections along line JK. Will the sections of the wall be the same size and shape? Explain. So one thing we want to make sure of is we're noticing that this is now showing a congruent figure and we're showing that they're marked with tick marks. So you can say that AJ is matching with KC. Okay. We know that AD matches with BC, and we know that DK matches with JB. So since they all have the same amount of lengths, that means the wall is divided evenly. between the two colors. Okay, so since all the corresponding angles and sides are congruent, the sections will be the same shape and size. So section of colors are same shape and size. Okay. You could even go further and just say, mention the angles. Angle A is congruent to angle B, which is congruent to angle C, which is congruent to angle D. Okay. And that's just going to help prove further that the two shapes are the same size and shape. All right, let's go ahead and talk about some theorems. We have first theorem 5.3. This is the properties of triangle congruence. For any triangle ABC, if ABC is congruent to ABC, that's the reflexive one. So this is kind of taking it back to chapter 1, chapter 2. Symmetric just means if ABC is equal to DEF, then DEF is equal to ABC. And then transitive, if ABC is equal to DEF and DEF is equal to JKL, then ABC is equal to JKL. Okay, equal, congruent, same kind of type of deal. Here's where we want to start with our third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So that just means if A matches with D and B matches with E, then C must match with F. Because if A is 30, I'm making up these numbers, and B is 60, that means C has to be 90, which means F would also have to be 90. Okay? So let's go ahead and try these. It says find the measure of angle BDC. So here's BDC. And I understand that they're overlapping right now. So one thing I would do is if you have two shapes overlapping, think about them as two separate shapes. A, C, D, and B, D, C. Okay? It says A is 45 degrees and then D is 30 degrees. Okay? If I already know that this is 45 and this is 30, I do have enough information to try to find angle C, right? So I would take maybe my 180 and just subtract the 45 and then subtract the 30. And then that should give me the angle measurement for C. So 180, double checking my math here, minus 45 minus 30 is 105. So that means C is 105, which means BDC, which is here, is also 105 because that is in the same corner as it is over here in the first triangle. Okay, so using third angles theorem, angle A corresponds to angle B, angle C corresponds to angle D, and angle D on the first one corresponds to angle C. Here's my matching one. Okay, so angle BDC is equal to 105. Okay. Next up, use the information in the figure to prove that ACD is a congruent triangle to CAB. Because we just talked about the reflexive and the symmetric and the transitive properties, it might be beneficial to use those. So my givens are, I know that AB is congruent to CD. I know that AD is congruent to BC. And I know that angle A on this side matches angle C. So by default, if angle A is congruent to angle C and angle C is congruent to angle A, by using the third triangle, the third angle theorem, angle D should be congruent to angle B using that third angles theorem. Okay, so AB is congruent to CD, that was given. AD is congruent to BC, that was also given. A is congruent to C, that's given. Technically, you can say C is congruent to A just by using the reflexive property. Okay. And then because we've proved that all of our angles and sides are congruent, we can say now that ACD is congruent to triangle CAB because all angles and sides are congruent. Okay, so this is just thoroughly talking about all the reasons why they can be congruent and together. Okay, that's going to conclude our notes today on lesson 5.2, Congruent Polygons. Thanks so much for choosing to tune in. Give this video a thumbs up if it helped you at all, and we hope to join